So, we will start freshly. So, I will give you some clear understanding on this Spark, okay? So, generally, I told you, right, Spark. So, this one we can either do it with the Python or the SQL as well. But I will tell you in the Python way, okay? Sorry, in the SQL way. Because if I have to tell in the how we can do with the Python, so before that you need to complete the Python course. Just a second. Okay. So generally, okay, we will have the basic understanding of the Spark. So once we complete, so initially I used to write and tell you, right? So I want to have some interactive and the pictorial session so that at least you will get some understanding how this can be done. So once we complete this, I will try to install the Spark in my local machine and we will see how those queries we can run it using Spark. Okay. So as I told you, Spark it's a distributed processing system. So I will tell you the difference also between the Spark and this Hive. So I will show you some pictures. You'll get some understanding. So in the Hive, I told you, right, we'll be using the Hadoop and all. So in the Spark, it uses the in-memory cache. Means it won't use any. Uh, uh, oh, sorry. So this Spark generally, using this Spark, we can connect to the any database. So these are the general databases we have. So this MySQL, Postgres, Hadoop, even using this Spark, we can connect to the Hadoop as well. So it's a top layer of the Hadoop. So either you can use the memory. You know about this RAM, right? Random access memory. So it won't store any memory. It only uses the memory to faster the processing. So that's how this Spark also works. So using so generally Spark it can be used with any database or the any application. So the general difference I'll show you. So if you see it here, if you Spark, if you are using Spark, let's example say I'm getting some data and I want to process it. If I completed step one, if I'm moving to step two after processing, it won't store anywhere. It will access only the RAM memory. Means cache. It's kind of a temporary memory where it will hold temporarily for certain time. That's it. So until the entire process is completed, it won't store information anywhere. So that's why compared to the Hadoop jobs, this Spark is very faster. So if you see here, we can use the Hadoop and we can get the data. Even in the middle also you can see entire the temporary memory only it is using. So that's how this Spark works. Even in case of this Hadoop, if you see for each and every step of processing, it has to store the data somewhere else. Means it has to it takes some time to store the data and it will get back the data and again it will do the processing. That's why this Spark one is better than the Hadoop one. So even if I tell you, yeah, yeah, it's the same only actually. So it was some the cache data it is showing, and between the each process. For example, I take this one. chunk of code. Once this code is completed, it is moving to another one. So in between, you see, this is a Hadoop environment. So where this is storing the data somewhere else, you can take this as a HDFS. Okay. So through disk and network, it will process. Okay. And if you see the differences, whereas in the Hadoop, you can see it. Uh, yeah. Just a second. Yeah. So using this Hadoop, you can integrate with many tools like uh, the tools which are internally available in the Hadoop only. Okay. Uh, Means if you want to use the Hive, the difference is like using Hive, you can only interact with the scoop, which is, in the Hadoop ecosystem, we have this one scoop. Even the Flume also, it's related to Hadoop ecosystem only. Let me show it to you. Yeah. So if you see here, so Hive, and we have this scoop or the pig, everything which is available internally in this Hadoop ecosystem only. Whereas in the Spark, it can access the APIs also. APIs, I will try to cover it in one day, okay? So API is nothing but a simple one link. Using that, you can fetch the data. So it can act with the APIs of the event Scala. So it won't need to access the entire application. It will, they will provide one link. Based on that web link only, you can access the data. You can perform the operations whichever you want. So that's the main difference. Here you need to access the entire application. Here you can access the API link. That's a difference you have. And okay, so the main another difference is like if you see the Hadoop requires a lot of disk space. I told you, right? Hadoop is related to a kind of big data where it will process with the large data set. It might be a 100 TB or it's more than that. So whereas in the Spark, it doesn't need any disk space. It only needs the RAM memory. Means it doesn't store the information anywhere. So we don't need the any database or the huge database size. That's the difference. And okay, so this Hadoop, if I tell you in the Hadoop, as I told you, it will be stored somewhere and the process happens and the you heard about the ETL. So anyone
Yeah,
possible?
extract, transform, and load.
Okay, yeah. So in general, uh, ETL is one of the process. You can either you can take any position in the data related, maybe a data analyst or data engineer, data scientist. So everyone will have to have the some basic understanding. So they will do some kind of ETL transformation, some kind of work over here, and it will store the data. So entire this thing happens in the batch form, means it has to go in a serial way. Whereas in the streaming process, you don't have to do in regular ETL form. Okay, so it kind of what should I say? How? So whatever the client and the storage, like the process is happening, it happens internally in the repeated way. So here, uh, you don't need to have any kind of ETL work. So you can directly access the memory, or you can do the transformations in the end also. That's the little difference. And yeah, so we see the differences in between the Hadoop and the Spark. So we already discussed, right? Hadoop is uh, it's related to a uh, where like it has some ecosystem where we do some distributed computing. Means whatever the work we are doing, it will be distributed in between many, you can say the processors or the, you can say the CPUs, it will be distributed over there. Whereas in the Spark one, it is not actually not related to any kind of ecosystem. It's a kind of a layer which is introduced on top of the Hadoop. Okay, so it's not related to Hadoop, but it is a, one of the technology it introduced on top of the Hadoop. So the design purpose also, we need large, uh, okay, we, generally it is designed to perform the large data or big data, you can say, where this Spark is developed to for the faster processing. This is for the storage purpose, to store the large data. Whereas uh, Hadoop will use one concept called the MapReduce. MapReduce, it's kind of where it will alter the stored information, means it will do kind of shuffling and it will execute it. Because of that, it will the processing will be a little slow. Whereas in the Spark, it won't do any kind of shuffling, where it will directly, whatever the data we have given, it will do the processing. Okay. So in the Hadoop
Instead of
also,
MapReduce only, we got Spark, right?
yeah, even this Spark also use the MapReduce, but not in all the scenarios. This Spark will use one concept called the data frame.
How Spark will use the MapReduce? Spark is replacing the MapReduce, right?
I will show you where it is. I think here should I have the uh, this yeah. So where this one? Yeah, this is the Spark core. Okay, I should have somewhere. This the ecosystem. Okay, I think. Just a second. I seen somewhere like even the Spark. It will also uh, work closely with the this MapReduce. Okay. RTD. Okay, it's not using. Okay. On this, I will take a confirmation and I will update it tomorrow. Okay.
Yeah.
So, okay. On the Spark, okay, we are using HDFS, no cloud. Yeah, and also we are using scheduler, it's related to Spark only. Okay. Okay. I will confirm this one tomorrow.
Yeah.
So, in general, this Hadoop, as I told you, right? It's kind of a fault tolerance, means to avoid any loss of the data and to avoid any loss, uh, like to loss the company and all. So what they will do exactly means they will keep the copies in the multiple disk. Means if you store some data one place, it will store up to 2 to 3 places. It's kind of a variable where uh, we can fix. So whereas in this Spark one, it used one concept called the RDD. So RDD, I will tell you in upcoming classes. So it can use this RDD and it can, so generally it doesn't have any data copies, okay? So, but it uses one concept called RDD. It's better than this Hadoop one for the processing. Yeah, here we have the MapReduce concept we discussed. So generally, this Hadoop will use this MapReduce for this batch processing. Whereas in this, yeah, I told you right, even the Spark also use the batch processing. So Spark along with the batch processing, it can even stream it can do the stream processing also. So this is one of the advantage with this Spark. Even it can do the both like batch processing and stream processing. Along with even it can run the machine learning algorithms also. So on top of the data, whatever we are processing, we'll apply some of the uh, uh, data predictions or the learning models. We can do it here. And okay, here in the Hadoop, we don't have the cache memory. So because of that, we need more disk space. Whereas in the Spark, we have we use morely the cache, so we don't need any other disk space. Okay, and whereas in the yeah, even I will show you the difference how much code we are writing. Maybe for example, in the Hadoop, if you want to code something, if it is taking maybe 50 lines of code, this can be done in maybe 10 lines in Spark itself. That's the even one of the difference we have. Till here it's clear, right? Or any doubts or questions?
Can continue.
Yeah, yeah. So this one we already discussed it. So for the fast processing, it encourages and yeah, internal memory. We don't need to access the outside of the memory. And the kind of coding we do, it's flexible compared to the Hadoop one. And it can be used for the better analytics means. So we use uh, for the data scientist and the team, mostly they go with this Spark only because it has some modules which are already exist with the functions which are related to any statistics or maybe related to this machine learning algorithms. So that's why it's a little better. Yeah, this one I was talking about the RTD. So RTD generally it's a collection of the elements like what are the data you are taking. So it can be it like be a this arrays, right? The uh, group of elements together. So that's how we can use or the tables, the data whatever you have, or the data frame. So the advantage with this uh, a Spark is we can use either we can use R, Scala, or Python, or we can use this SQL also. That's the advantage. Okay. In the Hive, we don't have this advantage. So we'll see what exactly this RDD is. And okay, yeah. So in general, if you want to like work with any Spark, so you can't work without this RDD. So how this works means, so whatever the coding or the work you are doing in front of it, so it's already created in the background. So whatever the functions you are utilizing, it's already created using these RDDs only. So it again depends. Like in some you might need to create, or Uh, in some of the cases, it's already available. Okay. So joins we discussed, right? So can we do the joining of two data sets? So we have, let's take, we have two different data sets. We have in the Spark, we have some functions using that we can do this joining also. This one we discussed, right, in the last previous class. This in the Hive also. The same for format we can do it. Yeah, it's the same with this aggregation also. I told you right, this minimum, maximum, count, sum, and average. So that kind of operations also this can be done here using this Spark. And uh,
Can you explain the architecture first before going to RDD if you don't mind?
yeah, it is okay. So just a second. So this is a Spark ecosystem, or you can say the Spark architecture. Okay. Uh,
No, I'm not asking about this ecosystem. How if it takes a file, how it will work?
okay.
Like what the cluster manager
Okay,
will
you
do?
are asking. Okay. So you're asking from the starting how the this Spark will take the data and how it will process, right?
Yeah, yeah, the architecture. Yeah.
Okay. I think in this we don't have that architecture. Let me see here. Oh, it is I'm trying to see. No, this one. This one. Just a second. Yeah. Yeah. Okay. So
No,
how this?
no, not this. I'm asking.
Okay.
You got the picture before, right? In the images session. You just open in the browser. Just go back. Yeah, this one right there. Yeah.
This one. I think.
Yeah, this one.
Okay. Okay. So generally how it works means, I told you right, this master and slave model. So
Yeah.
s- in the Spark also we have this uh, the main one and the task, just like a parent and child. So in this where we have this driver node, it will coordinate with the execution of all the tasks across the clusters. Okay. So with the worker nodes. So whatever the main the component we have, so it will interact with this driver nodes and it will take the task and it will execute it. So if I break down the architecture, initially how it this will be done here. Like initially, we have this stages called the job submission. So I told you, right, this scheduler. So just like that also, for each and everything, we have this scheduler where we will submit the Spark application to a driver node. So you can see the driver program here, right? So in this driver, whatever the application we are submitting, it will do the parsing of the application and it will create a one DAG. Uh, DAG means, how would I say? So we will create one DAG. So DAG is nothing but directed ac acrylic graph. Okay. So
Acyclic graph.
yeah. Directed acyclic graph. So where all the transformations will be executed. So even you're able to see the
It will store the data lineage.
yeah. So it's the same like the components we have in the cloud also in the AWS. The same DAG we'll use it here. And the next step would be like the stage creation. So whatever we have that this driver, it will divide that DAG into a stages, and it will do one operations. So kind of a shuffling between the nodes. So it has some stages like it will represent like for example, if you are providing some task to from the driver to the worker node, so it will be splitted in between multiple worker nodes in the parallel. So everything works in the parallel. Uh, okay. Till here it's clear, right?
Yeah.
Okay. So I told you, right, the control M. Just like control M also, we will submit some information to a this Spark job. Okay. Or the you can say the Spark application. Once the
Okay.
application is completed, it will create one staging.
What's the use of the driver program?
Driver program, it's a where it will acts as a main component, where the whatever the application the job you are providing, it will uh, do the splitting between the this nodes.
Okay.
So it will handle the entire process. This is a main component. Whatever the
Okay.
Spark here, you can see the context, right?
Yeah.
Means the
Okay.
so this will be communicated between the cluster manager and directly with the worker nodes as well.
Okay. Why cluster manager is it will allocate the resources, right, to the
Yeah,
worker nodes.
yeah.
Okay. Then how it will fetch the metadata?
Metadata, I don't see the component here. So in general, there would be one database in between this. Uh, or you can use the temporary files. So
Will
generally,
driver program will not uh, get the metadata?
no, in general, how they will do it means they will create one config entry. Means one config file they will create and they will place it. Or else they will use the format or the template of the metadata. So for example, uh, in the table, you don't have only one table, right? Or you don't work with only single data. So they will use internally this program will automatically fetch the details according to the table and it will modify the template. Means it will replace.
Yeah. But the table will not contain the metadata. It will just contain the data.
No, even we will have the columns also. Columns data also we will store it. So
In
from
which
that,
block the data is storing, all those details will not be there in the table, right?
no, that's how it
Then
not
how it
works.
will?
So in
Uh,
general, uh,
if if for suppose if the node is down, then
okay,
it has to work on the other node.
yeah,
So it has to fetch the data it has to fetch the data from some other node. So definitely it has to know the metadata only.
Yeah, so that metadata comes from the prior driver program only, because it is kind of an initiator.
Mm.
Even okay, you got it right.
Mm.
Okay, so I told you right, like we have this stage creation and the resource allocation. So in general, this driver will request for the resources. You can see it, or it is directly interacting with this. So it will it will ask for the CPU and the memory for the cluster management. If I say, so cluster management will only make this task work, not the other components like the memory allocation or the CPU allocation. So that will handle by this driver program only. So like this cluster would be anything like you can use this yarn. So yarn can act as a cluster manager, or we have one more component, mesos, that's also can act as a cluster manager. So this cluster manager mainly allocate this water the memory and we are giving, it will assign to this executors so that they can work on those uh, resources. So that would be the third stage actually. I think it might be written somewhere. Not here. Okay. Okay. This task scheduling, okay, that's I told you right. Based on the availability, like if one node is down, the entire work will be handled by either another node or it will create a one more backup of node. So that comes under this task scheduling. So where it will assign the task to a worker nodes based on the task dependency and the availability of the resources. So everything will be done in the parallel only. Like so once this is like we have this worker node and all the resources are available, it will do the data distribution. Like I told you, right? This
If
RDD.
suppose the worker node is dead, how will the driver program know that?
Sorry.
If suppose worker node is dead, it's not working,
Yeah.
or if the it's down for some time,
Uh,
how will the driver program will know immediately?
so if you see here, it's a kind of it will do the two-way directional communication between driver and the worker node. So even this cluster also will do it, but whatever the information passing, it will passes through from cluster to this worker node. Then it not comes to cluster manager. It will directly goes to the driver, which will give directions to the cluster manager how to react.
Then it will do half of the work.
Yeah, it
It will
will.
assign it will
Uh,
assign new worker node, and then it has to start the work again, or it will continue from where it has stopped.
no, it will. So it will take the last data where it is stopped. It will collect the information from there. It will discontinue that node and it will create another one. So that's how the database distribution happens. Even this partitioning and data distribution also happens in the same.
Okay.
And yeah, even like there are some more stages like okay, data distribution and yeah, this these will execute the process whatever we created, and internally they will create this intermediate results, means it won't directly pass the information. So they will create a temporary intermediate memory where they will store the information. And finally, what happens? Whatever the output we are getting, it will be merged together. It's kind of a, we say, result aggregation, or you can say the result merger. So where all the worker nodes, whatever the produced final output, it will be combined together. So it will be given with some serialing number. Based on that serialing number, it will do the merging. You got it right.
Mm.
So initially this would be a little confusing. So once you get into any project and you get a hands-on practice, like you will get some clear understanding. Because all the components, what am I saying? Everything is interdependent. Means uh, if I tell something here, you should know prior some other components or some other stuff before learning this one. That's why.
Mm.
So rest of guys able to follow, right? Or any doubts or questions you have? Okay. Where just a second. Okay. Uh, so shall I proceed with this Spark architecture?
Yes.
Okay, fine. Okay. In general, we know about this yarn. We already discussed previously. So, okay. Amazon is it? So, I would say these are some of the components where like even just like this Hadoop, we have some layers over here. So, okay. So yeah. So how exactly this will be done means, so example for say, we have this users, let's say us. So some persons might know the Java, some persons might know the Python, or some persons might know the R language, or some other may know the SQL or Scala. So based on their preference, they can create a layer, or it's already available. You can connect with this Spark and you can interact and you can create this data frames. So data frames, you can do the formation using, either you can do it with the uh, either Python you can do it, or you can use another programming language. So I would suggest like we can go with this SQL. So it would be easy. Okay. So where are we? Yeah. Okay. This data frames. So okay, it can be formed with the SQL like yeah, libraries. I would say in the just like in the Python, how we have the libraries, even in the Spark also we have. So with this, like let's say if you are using the Apache streaming, so in the streaming, either you can use Kafka or the Flume or Kinesis or some of the sockets, and you can connect with this. So how exactly it will do means, uh, it kind of even though it's a streaming one, if you observe if we observe keenly, we will see the some kind of a micro batch processing which will happen. Okay. So it will do one kind of technique where it will do the micro batching processing, like for each and every the process or the task, it will treat as a streaming, like kind of a sequential it will go. So so that's how it will present the streaming one. I would say. Uh, so for example, this is as much faster than so this micro batch processing will happens in the either milliseconds or in the nanoseconds. So in general, the source data, this streaming will done from the either API or the file systems. File systems means it will take the data either from the uh, any servers or the it will connect with the any uh, another environment one, or else it can do the sourcing with the Flowmark Kafka. So okay, this MLlib means uh, if you can see here, this can be data frames can be done with this SQL, and this the streaming can be done with either R or Java. So this ML, whatever you are seeing, it can be used with this Python. So if we want to perform some, uh, you heard about this clustering or the regressional algorithm or some kind of K-map and all. So we need to collaborate with this Python, or this Spark is not the Spark. This is a graphics. So it's a kind of API. It will use the network of graph analytics, where I would say uh, it moreover it will use this uh, some concepts called the vertices or the aggregative functions. So I would suggest instead of starting with this Scala or some other, you can go with this SQL one. It's a simpler one to use. So this one we have seen before, like just now I told you, right? The Spark core we already just discussed just now, where it is this one. So this is the main core of the Spark. Entire the operations will happen. So for the uh, data getting purpose, it will use any one of this layer. Yeah, again, this one is a common one. It acts as a data source. This one we already discussed. Actually, I don't have my laptop, so I'll try to install this Spark, and we will do some of the queries of this SQL data frames. You will get some understanding. Okay. Okay. Till here, any doubts or questions? Okay, fine.
No, you're good.
Okay. So I'll try to upload this document. This one we already discussed. The Hadoop we don't need. We already completed. Data lake concept, you know, right?
No.
Okay, data lake. Okay. In general, data lake, how it works means, uh, it works on the, uh, you know, this ETL, right? It totally reverse. It works in the ELT. It do the extraction, loading, and the transformation. So it has some layers actually, like this ingestion layer. Ingestion layer, it simply uh, it can get the data, and it can do the integration also from multiple sources, like either it can take the data from files or the databases, or from the applications, or what else we have, um, yeah, so any kind of database, like either it can be a structured database or unstructured database, it can ingest the data. So this is one of the layer. Once this is done, it can, sorry. So once this ingestion is done, it will comes to the, yeah, here we have, okay. So it can get the data, any kind of data into the storage layer. So storage layer compared to the regular one, it will be, I would say uh, 10 to 20 times the larger one. Means it can hold the raw data as well as the filtered data, any kind of data it will hold, where it will move the, in general, okay, it will do the processing. Process might happens again in the ETL one, and it will store the data in the data warehouse. So, okay, I would have this document. So dataware is simply the below version of the data lake. So in some projects, they might even use this data warehouse also, or single database, sorry, data warehouse, or combination of data lake and data warehouse. And that will be produced to the, either for the business intelligence or reports, or the consume, we will call it as a uh, downstream. Uh, so whatever we have this terminology in our projects, whatever the data we are getting from the ingestion, we will call it as a upstream, and the final layer will be called as a downstream. Means whatever, like we are providing the data to the downstream. You got it right, this data lake. Simply, I'll tell you the difference. It will follow the ELT one, this data lake. Even it can hold the raw data as well as transformer data, and it is larger than the regular, either you would say the database or data warehouse. The advantage with this data lake is like, so in the data warehouse, you will get only the transformer data, and you have the limited data. Let's say in the data warehouse, you might store the data maybe 100 GB, which we already lost some raw data around 300 GB. So the best part with this data lake is, even it can hold that 300 GB. You can go back and you can refer that data, and this uh, transformer data. So in the future, you don't need to refer, or you don't need to connect to the this uh, sources again. You already have the data with you. So in interviews, they might ask that's important one. This one we already discussed. Okay. No, not okay. In upcoming class, I will try to create any one of the sample codes and I will explain you. That would be easy for you. Okay. Uh, we will connect on Monday. So tomorrow I won't be available. So by tomorrow, like by Monday, I think my laptop will be recovered. So meanwhile, like I will upload the recording sessions and I will upload these documents also. You can refer the previous sessions. Okay.
Okay.
Okay. We will meet on the Monday. Okay. Yeah.
Sure.
Yeah. Thank you.
Thank you.
Thank you.